Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 23, 2025, about 9 days ago. It pulls together a practical, end-to-end recipe for code intelligence systems, showing how modern models reach over 95% success on benchmarks like human eval, while still struggling with real-world software engineering needs. The paper is titled, From Code Foundation Models to Agents and Applications, a Practical Guide to Code Intelligence. And, as we will see later, the way it connects training recipes to deployment challenges has big implications for anyone building serious coding assistants. Figure 1 sketches how software development shifts from purely human coding toward a code-intelligent era, driven by large language models and agents. The top cloud of topics shows the main pieces the authors focus on, like foundation models, multimodal code generation, software engineering agents, and coding safety. The lower timeline then illustrates 6 stages from manual coding and tool assistance through AI-assisted and AI-driven development, ending with a possible fully autonomous coding future. Figure 2 maps how the code intelligence ecosystem explodes from a few early models into a dense landscape of tools and agents by 2025. The main timeline in the center traces yearly waves of new code large language models, which branch into families like Code Llama and QN coders. The panels on the upper right highlight terminal tools and integrated development environment plugins, showing how these models migrate into everyday developer workflows. The cluster on the lower right marks 2025 systems that emphasize reinforcement learning, software engineering agents, and diffusion-based code generators, signaling a shift from just generating snippets to managing full software projects. Table 1 makes the point that this survey aims to be much more complete than past overviews of code intelligence. The table lists prior surveys down the left, then marks whether they cover code focus, large language models, pre-training, supervised fine-tuning, reinforcement learning, applications, and training recipes. Most earlier works address code or applications, but skip reinforcement learning and practical training details. The final row, labeled Hours, shows checkmarks in every column, signaling full lifecycle coverage. Figure 3 illustrates how code models have rapidly improved on the human eval benchmark, which measures how often generated code passes unit tests for small programming tasks. A broad upward arrow traces performance from early models around 2021 to current systems that consistently clear about 90% pass rate. The left side of the plot shows scattered early points, indicating modest success and wide variation between models. The dense cluster in the top right highlights recent models, which bunch together well above the -90% line, signaling a new plateau of near-expert performance. Figure 4 shows that real software engineering agents are steadily getting better at actually resolving repository-level bugs. SWE Bench Verified is a benchmark where a fix only counts if tests pass on a real codebase, so high scores reflect practical debugging power. The overall curve rises from single-digit success in 2024 with retrieval-augmented models to high double digits by 2025. The middle cluster highlights more capable agent setups with specialized coders and reasoning loops. The top right points mark the newest frontier models, which push SWE Bench Verified resolution toward roughly 70%. Figure 12 shows how a code model moves from raw text to an aligned assistant through 4 training steps. The left side covers pre-training and continual pre-training, where the model first learns general language from massive unlabeled text, then adapts to a specific domain with more focused raw data. The middle block, supervised fine-tuning, uses instruction-following examples, so the model learns to follow human-style prompts. On the right, reinforcement learning adjusts the model from preference data, which means trial and error updates based on human or automated feedback, to produce a better aligned model. So the big message is that code intelligence is no longer just about better autocomplete. It is an end-to-end pipeline from data and training recipes to agents that tackle real repositories, with safety and evaluation still lagging behind raw accuracy. The broader implication is clear. Future gains will come from domain specialization, verifiable feedback, and security-aware design. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.